Remember the homeostatic drive to sleep that we studied earlier in this lecture? Now let's revisit that model with more detail. Because the homeostatic sleep drive is linear, the longer we are awake, the stronger it becomes. It can be difficult to understand why we feel the least alert during an afternoon class around, say, 3:30 or 4, and actually more alert at around 8 p.m. And that is where Borbely's 1982 two-process model comes in, showing how the homeostatic sleep drive works in concert with your circadian alerting system. So first, the technical name for the homeostatic model is the two-process model, Borbely's, right? Remember that we have a quite linear homeostatic sleep drive, and it is called process S in this model, and S is just for sleep, easy to remember. And that process S builds up the longer that we are awake, right? It is represented in this picture by this gray area here. And see, it is building in a linear fashion, a straight line pretty much, over the entire daytime hours. And it decreases in a linear fashion as we sleep, right? However, this is counteracted by a C process, process C. So C as in circadian, and you see that represented in orange here. The alerting signal that is driven by your body's own circadian rhythm, independent of process S. So it is important to understand two things. First, that process C is not linear. Clearly, right? Look at that. It is influenced by the shape of your circadian rhythm. Two, it is important to know that process C, even though it is the alertness signal, is not your actual alertness. Alertness is produced by process S and C working in concert. It will be somewhere between those two lines. In particular, for someone who generally goes to bed at 11 and gets up around 6 o'clock, it looks something like this. So here's your alertness, your actual alertness in the middle, right? And now you can see how the influence on your alertness comes from both directions, right? From up here, from down here. And look at this, okay? Now that afternoon dip makes perfect sense. Now, what can affect process S, the sleep drive? Well, the amount of recent sleep and recent wake, right? What can affect process C, the circadian alertness signal? Factors that influence the human circadian rhythms are called Zeitgebers. Zeitgebers, don't you just love that word? Zeitgebers. Zeitgebers. Now, the Lord of the Zeitgebers, in other words, the most powerful one of all, by far, is natural light. But these are Zeitgebers too, albeit weaker ones. Social stimulation, exercise, meal times, room temperature, knowledge of the time, and even artificial light.